Now let's talk about wireless standards. If there's one underlying factor for why wireless has been so incredibly popular with users, it's the fact that it's so easy to configure and it just works. And that's thanks to the wireless standards that have been in place from the beginning. Now, the IEEE has adopted a number of standards for wireless networking, and each standard differs in terms of transmission speed, range, and the frequency that's used to provide the service. And these are some things you're going to have to memorize. I'm going to go over them here. I will include what you need to memorize on our study memorization sheet. It'll be out there in the working files folder for you. But keep in mind, the main thing you want to watch for here is the stated transmission speed and the frequency used. Range is going to be all over the place. If you go out and look on the internet at various reputable locations, you're going to see different ranges listed for the exact same wireless standard on different places. And that's just because it's really hard to pin these things down. So what I've done is kind of hit the average here for you, and you can still use that for planning. Now, there are 5 standards that you need to be familiar with on the Network Plus exam, and they are 802.11a, 802.11b, 802.11g, 802.11n, and then the newest kid on the block, 802.11ac. So let's go through these. 802.11a was actually the second wireless standard release. Guess what the first one was? 802.11b. It's a long story. Welcome to IT, okay? 802.11a. It gave us a speed of 54 megabits per second, which was really cool, although it gave us a range that was extremely disappointing, somewhere around 60 feet, and it would drop from there. And so this is the Achilles heel that kept 802.11a from ever being really popular, and it operated at 5 gigahertz. Now, the 5 gigahertz was most of the problem on the range because basic physics here, the higher the frequency, the more trouble it has going through solid objects like walls, ceilings, and so forth. And so the 5 gigahertz ended up being what caused the problem. 802.11a is incompatible with 802.11b and g, and by incompatible, that means if I have an 802.11a wireless access point, I cannot connect to it using a network card that's based on 802.11b or g. You'll see compatibility and incompatibility all over these things. 802.11b, the first real standard in the marketplace, ran at 11 megabits per second. Notice it gave us a 300-foot range and it operated at 2.4 gigahertz. Now, lower frequency gave us more range. However, that 2.4 gigahertz is an extremely crowded frequency, and in some locations, there's just a lot of interference, and it starts to cut down the range and the speed. 802.11b is compatible with 802.11g, and this greatly helped it in the marketplace. 802.11g gave us 54 megabits per second, a range somewhere between 150 and 300 feet. It operated at a frequency of 2.4 gigahertz, and it was compatible with 802.11b. Then along came 802.11n. This is probably the widely most adopted standard at this point. Notice the speed. Theoretically, this thing can ramp up to 600 megabits per second. You will never see that much speed in the real world, but you could get way up over 100, 200 megabits under the right conditions. The range on this is 300 feet and beyond under certain conditions. It can operate at either 2.4 or 5.0 gigahertz, and it is compatible with 802.11b. 802.11ac is the new kid on the block, and it's using some cool new technology we'll talk about in just a moment. Notice it's promising 500 megabits per second up to 1.3 gigabits per second. Now, the marketing stuff that you see out there is announcing that gigabit speed has arrived in the wireless world, and it has if you own a laboratory and you can recreate these perfect conditions. Otherwise, it's not going to happen for you, although some people have realistically hit 400 megabits per second. Pretty cool. Now, the range on this is somewhere starting at around 50 feet on the low side to about 150 feet, and the frequency is 5.0 gigahertz. Now, what's really happening, the secret to getting all the speed is, this is using an antenna technology called MIMO, whatever you want to call it. It means multiple input, multiple output. Now, what's going on under the hood, you're actually getting simultaneous data transmission over multiple antennas. So this one wireless access point, it's almost like multiple cores in a CPU. You actually really have more than one antenna in there, and each antenna is sending and receiving data independently of each other. And then there's a little multiplexer that's actually putting all the signals back together again and stripping them apart. And this is really neat stuff. And you're going to see more and more of this in the future. But this antenna technology is the secret for all the speed that's being promised and delivered by this thing. Now, keep in mind, all this information is going to be included in the memorization study sheet in the working files folder. I would use that, just memorize the standard name, the speed, the frequency, and generally those ranges, because you could see questions on the exam where you're needing certain speeds, certain ranges, certain frequencies because of interference, and just be able to work through those. By memorizing those, you can put them on that sheet before you start and make it a lot easier on yourself. So that's the wireless standards you need to be familiar with for the Network Plus exam.